Fuel identification. Until now, you needed a laboratory analysis to find out if your customer had filled up with the right fuel. Diesel, Super Plus, Super E10, Premium Unleaded. Just 4 possible types of fuel. But is the fuel in the fuel tank really the right one for the vehicle?
So, what's in the fuel tank? I'm sure you've been confronted with this question more than once in your everyday work. And on that note, welcome to Volkswagen TV. Until now, you've always had to wait for the result of the laboratory analysis. Now, you can use the VAS6774 to carry out an initial test, an initial analysis on site. How to do it and what initial analysis means. Dietrich Richter knows all about it. Hello.
Welcome to this training program from me too. The VAS6774 is a tool you can use for an initial analysis in the dealership, in your workshop, to identify the fuel in the fuel tank. It can't replace the laboratory analysis, that's important. But as you know, there are sometimes symptoms the customer is complaining about, but there is no entry in the event memory. That's when this tool comes into play. If there are symptoms indicating a fault, you can use it for an initial identification of the fuel.
Before you carry out the initial analysis, you should take a close look at the content of this case.
And we'll be doing just that. I open the case. And first of all, you'll notice this manual for the individual test steps. It's a non-verbal manual. That means there are illustrations explaining how to correctly carry out the individual steps. And because there are 2 test steps, I'll just turn the manual. And as you can see, there is a second test, the density measurement. Let me just put this away. We're about to start with the first test. As you could see from the manual, one main instrument is this graduated cylinder with a cleaning brush. In your daily work at the workshop, this bracket in the lid of the case can be used to ensure the cylinder's stability. Now it's stable. Its position should be perpendicular. To adjust it, you can use the box of the hydrometer, which we'll be needing for a later test step. We also have an electric testing device. This comes with a connector cable, which is to ensure the device's voltage supply from the cigarette lighter. However, there is also a small adapter cable. So with these clamps, you can also use the vehicle's battery for the supply. Of course, you then have to connect the adapter to the connector for the cigarette lighter. This ensures the current supply for the measuring instrument. The measuring instrument itself consists of 2 parts: the tester and the sensor head. The purpose of the sensor head is to detect petrol residues in the diesel fuel.
I can also see some white stickers. What are they for?
First of all, they aren't just normal stickers, but diaphragms. Let's have a closer look. I'll take out one strip. What's characteristic for them is that they are permeable to gases but moisture repellent. Their purpose is to protect the sensor head from fluids because it has to be protected against them.
I noticed that cleaning equipment is included. Why is that?
When it comes to tools and the workshop, it's always important that everything is clean. That's also good for the measurement results. And it's vital that this measuring instrument is kept clean, because we don't want the results of later measurements to be incorrect. But more on that later in the program.
If the customer's complaint leads you to assume that the fuel is contaminated, you first of all need 500 milliliters of this fuel for the analysis. How do you get it?
It depends on the model and maybe even on the engine version. There are different procedures. Always refer to the workshop manual to see what's best in your specific case. For our Tiguan, we select, of course, Power Unit, then Repair Group 20 for the fuel supply. There you'd also find information on what to do in the case of misfueling. But we'll select Emptying Fuel Tank. And once you've clicked on that, you get a detailed explanation of how to withdraw this small amount of fuel from the tank. Depending on the fuel level, you might even be able to do this via the fuel filler neck.
With the VAS6774, you can carry out two different tests. On the one hand, you can test the density of all fuels. On the other, you can test diesel fuels for petrol residues. For this test, you need the measuring instrument and the sensor.
That's right, and we'll begin with the first step of this first measurement right away. By sticking on a diaphragm, we protect the sensor head against moisture getting in. The diaphragm is placed into this indentation in the sensor head. Press it on, and put the diaphragms you don't need back into the original packing. In this way, they're protected against dirt, and you can use them another time. Now the sensor head is prepared. Next is the electrical connection. Of course, I'll use these two cables to use the vehicle's battery for the measuring instrument's voltage supply. I'll connect the adapter cable, and now I'll connect the connector for the cigarette lighter with the adapter cable. Please make sure that they're pressed together properly to ensure that the voltage supply is working properly. I'll just bring the tester to an upright position so you can see it better. Down here is a test button, which I press. As you can see, an LED starts flashing. This indicates that a self-test is being carried out. It will take about 1 minute.
What exactly does this measurement tell us?
This measurement will tell us if there's petrol in the diesel fuel. Diesel fuel is a particular fuel for particular engines. There must not be any petrol in it. If there was petrol in it, the vehicle's performance would suffer, and that's what this test will tell us.
Is there a minimum quantity of petrol which has to be contained in the diesel so the instrument is able to detect it at all?
This identification device is very sensitive. To demonstrate this for you, I'll put a few droplets of petrol into this graduated cylinder. Now I'll fill it up with diesel fuel. We mentioned earlier that we need about half a liter of this fuel. I deliberately put the droplets of petrol on the bottom of the graduated cylinder to prevent the impression that the measurement only gives a correct result if they are floating on top of the diesel fuel. That's why I put the petrol on the very bottom of the graduated cylinder. Of course, they also blend. Next, we take the sensor head. Here it has a breather valve. I recommend slightly wetting this rubber ring, because that makes inserting the sensor head easier. Keep the breather valve pressed so the air, which is displaced by the sensor head, can be released up here. And now everything is ready to test for our petrol residues.
And what exactly happens during the measurement?
Well, I have to start it first. The LEDs aren't doing anything, so the self-test is over. And now I'll kick off the test for petrol residues. You can see an alternating flashing of the LEDs. As long as they're doing this, the test is being carried out. What exactly happens during this test? Well, at and above 0 degrees Celsius, petrol starts to evaporate from the diesel. The diaphragm is permeable to gases, thus evaporating petrol also reaches the sensor head, and we get a reading. Is there petrol in the diesel or not?
So, it's vital to carry out this test for petrol residues first. Why?
If you suspect that there's petrol in the diesel, it's important you do this one first, because it might only be a very small amount. Our test is still being carried out. And if you, say, work with the hydrometer or transfer the liquid first, you run the risk that the petrol has already evaporated from the diesel fuel, and you'll get a wrong reading. To make sure your results are correct, do this test for petrol residues first.
The instrument still needs a little time. What exactly are we seeing here?
So far, there are only the 2 flashing LEDs on the measuring instrument. What's important is that in this cylinder, fuel is evaporating. To explain this, let's look at an animation. There is diesel in the graduated cylinder and a few parts of petrol. As I said, they're evaporating. That's what our sensor will detect up here. The gases with the petrol's hydrocarbons. There are also hydrocarbons in diesel, but they're not as volatile as those in petrol. Here we have 2 smileys. One happy, one rather sad. If our result is okay, that means no petrol in the diesel, a green LED comes on below the happy smiley. That means the fuel is okay. If there's petrol in the diesel, a red LED below the sad smiley comes on. That means the diesel fuel contains petrol.
The result is ready. The red LED is on, so the instrument has detected the small amount of petrol. The first test is finished. Next is the density measurement.
That's right. To do this, we'll need the hydrometer and an open graduated cylinder. That's why, first of all, I'll remove the sensor head. I'll just wipe it a bit and put it down here on the case. Now the hydrometer comes into play. Of course, I will continue to use its box to maintain the cylinder in as upright a position as possible. Here we go. This hydrometer has a glass shaft with a weight at the bottom. When you insert it carefully, you have to make sure not to drop it. It has to float in the middle. And of course, you have to read off a value. The hydrometer must not touch the walls of the cylinder. It has to float freely, and if we read this value off, we see that it's between 10 and 11. This is the value corresponding to a European fuel meeting the EN 590 standard.
With the hydrometer, you determined that in this first cylinder there is diesel that complies with the European standard. But fuels are very diverse. Of course, they're different. Can you use the hydrometer to determine what kind of fuel it is?
Basically, we use the hydrometer to give us an initial idea. And yes, it's possible to differentiate. That's why the hydrometer's value range is rather large. Let's use cylinder 1 as a first example. That's where we'll begin. As you can see, the color isn't enough to determine which fluid it is. I carefully insert the hydrometer and make sure that it's floating in the middle. As you can see, there isn't even a value we could read off the hydrometer. It's almost jumping out of the graduated cylinder. If you look at this chart, which you also find in the guided fault finding, you'll see that the value is higher than 17. So the density resembles that of water, and that's correct. What we have here is tap water. The second example, again we're using the hydrometer and the indicated values to determine which fuel this might be. The value is a bit higher than 10. This means it's a fuel meeting the EN 590 standard in Europe. Yes, it's a European high-performance fuel made by an oil company. Let's compare this with the value of a diesel fuel of the same brand, but this time it's regular diesel. As you can see, this fuel's density is slightly higher. It's 11, so it's still within the range of tolerance of a standardized European fuel. On to the fourth example. Again, the liquid is almost colorless, and again you have to insert the hydrometer as carefully as possible. It has to float in the middle. The value we read off is about 8.2. A look on our reference chart tells us that it could be a mixture that's neither petrol nor diesel, or a bioethanol mixture. And indeed, here I've filled in a bioethanol mixture. Let's continue with the fifth example, with a more intense color. Again, I carefully insert the hydrometer. It's quite probably a diesel fuel, but the density is about 8. So we have to take a look at our reference chart. It looks like diesel. The density is between 7 and 9. And yes, here we have a fuel mixture consisting of about 1/3 petrol and 2/3 diesel fuel. In cases like this, you have to pass the samples on for laboratory analysis after the initial identification. There still is the sixth cylinder left, and here you'll see why it's important to go about it carefully and slowly when you insert the hydrometer and let it float. To demonstrate this to you, I'll drop it, and as you can see, this hydrometer sinks to the very bottom, and we get a value of about 3. Let's look at the chart. From 0 to 5.5. And 3 lies in between. So in our case, the cylinder contains petrol.
Let's talk about cleaning. For the hydrometer, it's enough to give it a quick rinse with water and dry it off with a cloth. It's different for the graduated cylinder though. First, you have to dispose of the fuel in accordance with regulations. Then, you must wash out the whole graduated cylinder.
You have to clean the graduated cylinder VAS6774/2 with warm water and a commercially available degreasing cleaner with a pH value between 7 and 9. Move the brush that's applied up and down in the cylinder at least 20 times. This is the only way to remove all fuel residues from the inside of the graduated cylinder. Finally, rinse the graduated cylinder well with clear water and let it dry upside down.
You've cleaned this graduated cylinder, but it still smells a bit of fuel. Is it really clean now?
The cylinder is clean and has been cleaned properly. However, the plastic cylinder might still smell of fuel. But of course you can test if there are any residual traces of hydrocarbons, that is, of petrol, by fixing the cylinder, putting on the sensor head and testing for petrol residues. Then you'll know whether the cylinder is clean and just smells of fuel, or whether you need to clean it some more.
You've just mentioned that you should use commercially available cleaners for the cleaning procedure. Is there one you can recommend as being especially suitable?
No recommendation is necessary. This cleaning procedure has been tested in the lab and all cleaners give good results. However, it's crucial to use warm water. It's the only way to ensure the degreasing components are truly effective.
This goes for the VAS6774 as for any other measuring instrument. Only if all the components are intact can it produce correct results. What do you have to keep in mind?
Make absolutely sure never to use the sensor head without a diaphragm. The diaphragm protects the sensor head against moisture getting in. Never use the sensor head without a diaphragm. The diaphragm is for one-time use only. Dispose of it when you've finished the measurement. If you look at the sensor head without a diaphragm, you can clearly see a metal mesh down there. Please make sure to protect that from mechanical damage. Never try to clean it with a screwdriver, you would destroy it. Chips would destroy the sensor element. There is a third thing you must not do. Never blow compressed air into this sensor head. That would destroy the sensor element too, making the device unusable.
After cleaning it, I just put the hydrometer in the case. It can't roll away, but I'm guessing it's not stored properly yet.
You're right. The same goes for all other components and tools which belong in this case. Let's begin with the hydrometer. There is a box to transport it in. Make sure the hydrometer is never bent, so put it into this box. This means that it's protected, and in this compartment here, it's stored properly. Unfasten the graduated cylinder, put the brush into it, and put it into its compartment. Of course, the same goes for the sensor head and the measuring instrument connected to it. The cables are put into their compartment as well, including the adapter cable, of course, so your colleagues can perform measurements too. The manual is put into the case, and then you can close the case and put it away.
The case has been closed. You've passed on all information. Thank you.
No problem. And to you. Have a good day at work. Bye.
With the VAS6774, you can do an initial analysis of fuels. How this is done correctly, here's a summary for you.
You can use the VAS6774 for a density test and to test diesel fuel for petrol residues. Everything you need is included in the tool case. First of all, clip the graduated cylinder into the corresponding bracket in the case's lid. Start with the petrol residue test. To do that, first of all put a diaphragm on the sensor head. This will stop liquid from entering and thus damaging the sensor head. Put the diaphragms you're not using back in the bag. They must not get dirty. Next, connect the measuring instrument either to the cigarette lighter or with the connecting cable that's supplied directly to the vehicle battery. Press the test button on the measuring instrument. The instrument is being activated. After about 1 minute, it's ready for use. The green LED on the left of the test button is on. For the test, fill 500 milliliters from the fuel tank in question into the graduated cylinder. It's vital that you start the petrol residue test right away, because any hydrocarbons that might be in the fuel mixture are highly volatile and would not be measurable later on. That would mean that it would no longer be possible to use the VAS6774 to identify the fuel. Put the sensor head on the graduated cylinder and press the button at the side of the sensor head. The pressure is equalized. Press the test button again. The sensor checks whether any amount of petrol is contained in the fuel mixture. After about 3 minutes, you get the result. If no petrol is contained in the diesel, the green LED on the left is on. If the red LED on the right is on permanently, this indicates petrol in the diesel fuel. The test is over. The green LED is on, so no petrol could be measured in the diesel. In the second step of the measurement, the density of the fuel is determined. Remove the sensor head from the graduated cylinder and insert the hydrometer carefully into the graduated cylinder. Make sure that the hydrometer is floating freely in the graduated cylinder and that it's not in contact with its walls to ensure a result you can work with. Read the value off the hydrometer and compare the figure with the information on the different fuel densities in the guided fault finding. Once you have finished the tests, first remove the diaphragm from the sensor head and put the measuring instrument back into the case. Next, clean the hydrometer with a cloth and put it back into its plastic box. Finally, rinse the graduated cylinder as recommended.